How an electric kettle works. Every morning, millions of people start their day by filling a kettle with water, pressing a switch, and waiting for it to boil. It seems so ordinary that we rarely stop to think about what is happening inside. Yet this small appliance is a clever piece of engineering, combining electricity, heat, and safety systems to give us hot water in just a few minutes. The hidden power of the heating element at the core of every kettle is the heating element. In older designs, it was a visible coil, but in most modern kettles, it is a flat metal plate at the bottom. When you press the switch, electricity flows from the socket into this element. The material resists the flow of current, and that resistance is what generates heat. The process is called joule heating. Whenever electricity meets resistance, energy turns into heat. Because the coil or plate is in direct contact with the base of the kettle, the heat quickly transfers into the water above it. Metals conduct heat very well, so within seconds the bottom layer of water begins to warm. From gentle warming to rolling boil at first, the water molecules just move a little faster, raising the temperature slowly. You may see tiny air bubbles forming on the metal surface. These are dissolved gases escaping as the water warms. As the temperature climbs closer to 100 degrees Celsius, the bubbles grow larger, and soon the entire kettle seems alive with movement. When water reaches its boiling point, the liquid changes into gas. Large bubbles of steam rise rapidly, and the surface of the water roils and churns. This familiar rolling boil is the kettle's signal that the water is ready. The clever automatic switch, one of the most impressive parts of the kettle, is how it knows when to stop. Without an automatic shutoff, the water would keep boiling until it evaporated completely, which would be both dangerous and wasteful. The solution is the bimetallic thermostat built into the switch. This tiny device contains two different metals joined together. Metals expand when heated, but each metal expands at a slightly different rate. As steam rises inside the kettle, it channels through a small tube toward the thermostat. The heat makes the two metals bend. When they bend far enough, they push a mechanism that snaps the switch open, cutting off the electricity. That familiar click you hear when the kettle turns off is the sound of the thermostat doing its job. Safety systems built in manufacturers know that people sometimes forget to add water before switching on the kettle. That could destroy the heating element. To prevent this, modern kettles have dry boil protection. If the element gets too hot without water to absorb the heat, the thermostat senses the temperature rise and immediately switches off the current. Some kettles also include thermal fuses, one-time safety devices that permanently cut power if the kettle ever overheats severely. The body and materials kettles come in plastic, glass, or stainless steel, but all serve the same purpose: to insulate heat, protect the user, and house the working parts. Stainless steel kettles are durable and keep heat well. Glass kettles let you watch the boiling process. Plastic kettles are lightweight and inexpensive. The lid, handle, and spout are carefully designed too. The lid keeps steam from escaping too early. The handle is made of heat-resistant material, so you can lift it safely, and the spout directs the hot water without splashing. Energy efficiency and speed. Electric kettles are surprisingly efficient. Almost all the electrical energy is converted into heat inside the water. That's why they usually boil faster than heating water on a stove. The only real energy lost is a little through the kettle's walls and lid as steam escapes. The speed also depends on the power rating. A small kettle might use 1500 watts, while larger or faster boiling models can be 2000 to 3000 watts. The higher the wattage, the quicker the boil. Beyond the basics, some modern kettles include extra features. Temperature control, so you can heat water to exactly 70 degrees Celsius or 80 degrees Celsius for green tea or coffee. Keep warm functions that maintain a set temperature. Illuminated glass bodies so you can see the rolling boil more clearly. All of these build on the same principle. Electricity heats a coil, the coil heats the water, and a thermostat ensures safety. A small machine. A big convenience. The beauty of the kettle is its simplicity. In just a few minutes, it takes cold water and turns it into boiling water, ready for tea, coffee, or cooking. Every part, from the heating element to the automatic shutoff, is there to make the process quick, efficient, and safe. Next time you hear that satisfying click and see the steam rising, remember that your kettle is not just a container with a plug. It is a carefully designed machine that turns invisible electrical energy into heat and then into boiling water, all while protecting you and itself. That it's everyday science at work, hidden in plain sight on your kitchen counter.